Have you ever witnessed daylight suddenly turning into mysterious twilight darkness completely? It feels unreal when the sun disappears in broad daylight sky above us. This breathtaking phenomenon is known as a solar eclipse event of nature. People across history feared and worshipped these rare celestial moments deeply always. But what actually causes a solar eclipse to occur precisely in space? Today, we will explore the science behind solar eclipses clearly together now. You will discover why they happen and why they seem rare indeed. Get ready, because this journey through space will amaze your mind deeply. Imagine standing under a darkened sky during the daytime, suddenly changing rapidly. Birds stop singing, and temperature drops within just a few minutes swiftly. That is the dramatic effect of a total solar eclipse event unfolding. But such events do not happen every month or year as expected naturally. They require precise alignment between Earth, Moon, and Sun positions in space geometry. This alignment is what makes solar eclipses extremely fascinating, scientifically observable events. Many people travel across countries just to witness totality, once-in-lifetime experience. The path of total eclipse is surprisingly narrow on Earth's surface region. Only a small region experiences full darkness during total eclipse phase briefly. Elsewhere, people see only partial or no eclipse at all visibility difference. This makes each solar eclipse a rare geographical experience, globally unique phenomenon. Ancient civilizations often interpreted eclipses as powerful divine messages from heaven's above sky. Modern science now explains them using orbital mechanics precisely with calculations models today. Solar eclipses happen when Moon blocks Sun from Earth view completely alignment. This happens only during a specific lunar phase called new moon cycle. The Moon's orbit is slightly tilted compared to Earth's orbit plane system. Because of this tilt, eclipses do not occur every month cycle regularly. They only occur when alignment is perfectly straight and exact position timing. This precision makes eclipses scientifically predictable, yet still visually rare phenomena observed. Astronomers can calculate eclipse paths many years in advance, accurately using models. Despite predictions, witnessing one remains an emotional, unforgettable experience for observers worldwide. Total eclipses last only a few minutes, at most maximum duration period. Partial eclipses are more common, but less visually dramatic overall effect observed. The shadow of the Moon creates two regions on Earth's surface areas. These regions are called the umbra and penumbra shadow zones, scientifically defined. Umbra causes total darkness, whilst penumbra causes partial shading effect variation observed. This difference explains why eclipse experiences vary across locations globally significantly observed. Some regions experience complete darkness, whilst others see partial light only briefly. The Sun is 400 times larger than the Moon object comparison scale, but it is also about 400 times farther away, distance balance phenomenon. This cosmic coincidence allows perfect solar eclipse alignment, possible rare geometry event. Without this balance, total eclipses would not occur at all naturally ever. This makes Earth uniquely privileged for observing total solar eclipses events naturally. Other planets may experience eclipses, but not like Earth does observe uniquely. Scientists study eclipses to understand solar atmosphere better today, corona research insights. During totality, the Sun's corona becomes visible briefly for scientific observation study. This moment provides rare opportunity for astronomical research discoveries, important scientific insights. Eclipses have influenced myths, cultures, and human imagination for centuries, deeply worldwide. Some ancient societies believed dragons were swallowing the sun during eclipse events. Others performed rituals to bring the sun back into sky again quickly. Today, we understand these events through precise scientific calculation methods accurately applied. Yet fascination remains strong amongst people watching eclipses globally today, everywhere still. Each eclipse reminds us of cosmic scale and precision universe beautifully aligned. Even small changes in orbit would prevent eclipses entirely occurring naturally ever. This shows how delicate celestial mechanics truly are in our universe system. Understanding eclipses helps us appreciate Earth's place in space, universe perspective deeply. It also connects science with wonder and human curiosity, emotion exploration deeply. People often feel humbled when witnessing total solar eclipse phenomenon, naturally profound. Now let's dive deeper into how solar eclipses actually begin forming in space. Everything starts with the constant motion of Earth, Moon, and Sun together. These celestial bodies follow precise orbits governed by gravitational forces always acting. The Moon circles Earth roughly once every 27 days, continuously repeating. But its orbit is slightly tilted relative to Earth's orbital plane system. This tilt is the key reason eclipses do not happen every month. When the Moon crosses Earth's orbital plane, alignment becomes possible briefly. Only during this alignment can a solar eclipse potentially occur naturally. Imagine three giant objects aligning perfectly in a straight cosmic line. That alignment is extremely rare considering vast distances and orbital variations always. Even a small deviation can prevent eclipse formation entirely in space. This is why eclipses feel like special-timed cosmic events always. Scientists call this precise alignment a syzygy in astronomical terminology usage. During syzygy, the Moon passes directly between Earth and the Sun position. This blocks sunlight partially or completely depending on viewing location on Earth. People standing in different regions experience different levels of eclipse visibility. Some see total darkness, while others see only partial shadow coverage. This variation creates unique experiences for observers across different geographic regions worldwide. The Moon's shadow travels across Earth's surface at incredible speeds always. This shadow path is called the eclipse path of totality, scientifically defined. Within this narrow path, observers witness the full solar eclipse experience. Outside this path, only partial eclipse effects can be observed visually. The speed of the shadow depends on orbital motion and geometry factors. Sometimes the shadow races across Earth faster than a jet airplane. This makes eclipse viewing locations very time-sensitive and carefully planned. Many enthusiasts travel thousands of kilometers just to reach totality zones. Weather conditions also play a crucial role in visibility success outcomes. Even perfect alignment can be hidden behind clouds at critical moments. This adds uncertainty and excitement to eclipse-chasing experiences worldwide communities. The Sun appears completely blacked out during total eclipse moments briefly. But its outer atmosphere, called the corona, becomes visible beautifully glowing. This corona is usually hidden by the Sun's extreme brightness, intensity always. During eclipse, scientists get rare opportunity to study solar outer layers. This helps improve understanding of solar winds and space weather behavior. Solar activity can affect satellites' communication systems and even power grids. So eclipses are not only visual events but scientific research opportunities. The temperature on Earth drops noticeably during total eclipse phases quickly. This sudden cooling affects animals' behavior and natural environmental responses observed. Birds may stop flying and return to nests during eclipse darkness. Some animals become confused, thinking night has suddenly arrived unexpectedly fast. Humans also experience emotional reactions, seeing daylight turn into twilight darkness. This emotional impact makes eclipses unforgettable, lifelong memories for many observers. Ancient cultures recorded eclipses in stone carvings and historical astronomical records. These records helped modern scientists understand long-term eclipse cycles accurately. Today, we can predict eclipses thousands of years into future precisely. This accuracy comes from understanding gravitational physics and orbital mechanics deeply studied. Yet even with prediction, witnessing remains awe-inspiring experience every time. The combination of predictability and rarity creates powerful fascination among people. Each eclipse follows a specific cycle known as the Saros cycle. This cycle repeats roughly every 18 years and 11 days period. Eclipses separated by this cycle share similar geometry and appearance characteristics. This helps astronomers study long-term patterns in celestial alignment behavior. The Moon slowly moves away from Earth over millions of years gradually. This means future eclipses will eventually change in appearance and frequency. Right now, we live in a unique era of perfect eclipse visibility. Understanding this makes each eclipse even more valuable scientifically and emotionally. The next part will reveal surprising hidden truths about eclipse rarity. We will explore why total eclipses are far rarer than expected. You will discover cosmic coincidences that make them almost miraculous events. Now we reach the part where solar eclipses become truly surprising and mysterious, because what you think you know about their rarity is not complete. Many people assume eclipses are common events happening regularly across Earth. But the reality is far more precise and mathematically restrictive than expected. Even though alignments happen, perfect visibility is extremely limited, always globally. The Moon's shadow covers only a tiny fraction of Earth's surface area. That means most people will never experience total eclipse in lifetime. In fact, location determines whether you see anything at all clearly. You could be just hundreds of kilometers away and miss everything completely. This geographic limitation makes solar eclipses extremely rare personal experiences. But here is the twist that changes everything about eclipse perception. Eclipses are not rare in space, but rare in human experience. On average, Earth gets 2 to 5 solar eclipses every year. That sounds frequent until you consider visibility from one location. From a single city, a total eclipse may occur once centuries. This means your lifetime chances are extremely low for totality viewing. Even partial eclipses vary widely depending on shadow path movement patterns. The Moon's shadow only lasts a few minutes at any location. That short duration makes observation window incredibly narrow and precious always. Another surprising fact is that eclipses follow predictable repeating cycles. Yet even predictable events still feel unpredictable emotionally to observers. This contrast between science and emotion creates powerful human fascination always. Ancient astronomers noticed repeating patterns, but could not explain them fully. Modern science revealed gravitational interactions controlling these precise orbital alignments. Still, the feeling of witnessing eclipse remains almost magical for viewers. Here comes another deeper insight that surprises many science learners today. The Sun and Moon appear almost identical in size from Earth view. This is not coincidence, but rare geometric alignment in cosmic scale. The Sun is vastly larger, yet also much farther away, distance balance. This creates perfect visual overlap during total eclipse events occurring naturally. Without this exact ratio, total eclipses would not exist at all. This makes Earth uniquely capable of experiencing such perfect celestial alignments. No other known planet has this same eclipse perfection combination observed. This fact alone makes eclipses scientifically extraordinary and deeply significant globally. But there is still more hidden complexity behind eclipse rarity mechanisms. The Moon's orbit slowly shifts over time due to gravitational forces. This changes eclipse patterns gradually across thousands and millions of years. In ancient times, eclipses were slightly more frequent than today. In distant future, total eclipses may become less common or disappear. This means we are living in a rare cosmic window right now. Another twist is that not all eclipses are visually equal in experience. Some total eclipses last longer, depending on orbital distance variations. When Moon is closer to Earth, eclipse duration becomes slightly longer. When farther away, it may not fully cover the Sun completely. These subtle variations create dramatically different visual experiences each time. Scientists carefully study these differences to understand orbital dynamics better. Eclipse photography has also revealed new insights into solar corona structure. The corona changes shape depending on solar activity cycles and magnetic fields. This means each eclipse shows a unique version of the Sun's atmosphere. No two eclipses are ever exactly identical in appearance or effect. That uniqueness adds emotional depth to every eclipse viewing experience. Even experienced astronomers feel awe during each new eclipse event. The combination of rarity and predictability makes eclipses deeply powerful phenomena. It is science that feels like poetry written in the sky. And now we are ready to move into deeper final understanding. The next part will bring everything together into a powerful conclusion. You will see why eclipses matter beyond just visual beauty alone. There is a final lesson hidden inside these cosmic alignments, always, and it will change how you see the universe forever completely. The story of eclipses is still unfolding with new discoveries ahead. Every eclipse adds another piece to our cosmic understanding, slowly growing. Humanity continues to learn from these rare celestial alignments over time. And what comes next will complete this journey of discovery. Prepare for the final insight that ties everything together. Now we arrive at the deeper meaning behind solar eclipses and their impact. These events are not just astronomical, but deeply emotional human experiences. People often describe feeling a sudden sense of smallness during totality. It is as if the universe pauses for a brief, silent moment. That silence creates a powerful connection between humans and the cosmos. But there is also a scientific side that explains this emotional response. When daylight disappears, our biological rhythms react instantly to darkness. The brain interprets this sudden change as an unusual environmental shift. This triggers both curiosity and instinctive emotional alertness in humans. That is why eclipses feel so unforgettable, even after just minutes. Now let's explore another surprising truth about eclipse visibility patterns. Solar eclipses move across Earth in long, narrow paths of shadow. These paths can stretch thousands of kilometers across continents and oceans. However, only a small strip experiences full totality directly overhead. Outside that strip, the eclipse appears partial and less dramatic visually. This creates a global inequality in eclipse viewing experiences every time. Some people wait decades, while others may never see one at all. That randomness adds to the mystery and emotional value of eclipses. Scientists use satellite data to map eclipse paths with extreme precision. These predictions allow people to travel to the best viewing locations. Eclipse tourism has grown into a global phenomenon in recent years. Entire cities prepare for sudden influx of visitors during eclipse events. Hotels sell out months or even years in advance for eclipse dates. This shows how powerful natural events can influence human behavior strongly. But beyond travel and excitement lies an even deeper scientific purpose. During total eclipse, the sun's corona becomes visible to telescopes clearly. This helps researchers study solar flares and magnetic field structures directly. These observations are impossible under normal daylight conditions due to brightness. Therefore, eclipses act like natural laboratories in outer space research. Many major solar discoveries were made during eclipse observation campaigns historically. Even today, scientists launch experiments specifically for eclipse events worldwide. Another hidden aspect is how eclipses affect animal behavior significantly. Birds often become confused and stop their normal flight patterns suddenly. Some nocturnal animals become active as darkness temporarily appears during day. This temporary disruption shows how life depends on sunlight cycles deeply. Humans also feel subtle changes in mood and perception during eclipses. The sudden drop in temperature adds to the surreal atmosphere experienced. Wind patterns can shift slightly due to rapid cooling effects locally. These environmental changes are small but scientifically measurable during totality. This makes eclipses useful for studying atmospheric reactions to light loss. Ancient records show how civilizations tracked these environmental changes carefully. They used eclipses to measure time and predict future celestial events. Modern science has refined these predictions to extremely accurate levels today. Yet even with precision, the emotional impact remains unpredictable always. That combination of control and surprise makes eclipses uniquely powerful phenomena. Another twist is how eclipses connect us to cosmic timescales. Each eclipse is part of long repeating cycles lasting thousands of years. These cycles show that celestial mechanics operate with incredible long-term stability. Still, small orbital changes gradually reshape eclipse patterns over time. This means every eclipse we see is part of a changing universe. Understanding this gives us perspective on Earth's fragile cosmic position. We realize how perfectly balanced conditions allow eclipses to exist. Without this balance, such beautiful phenomena would never be visible. This makes each eclipse a rare gift from cosmic alignment itself. Scientists continue to study these patterns to understand planetary systems better. Every observation adds new knowledge to our understanding of space. And every eclipse becomes a data point in universal exploration efforts. But the final message of eclipses goes beyond science alone entirely. It is about connection, curiosity, and wonder across human generations. And now we move toward the final conclusion of this journey. Everything we learned will come together in the last section. The meaning of eclipses becomes even clearer in the final reflection. Prepare for the closing insight that ties science and wonder together. The universe still. Now we reach the final part of our journey into solar eclipses. Everything we explored now comes together into one powerful understanding. Solar eclipses are not just events, but cosmic reminders of precision. They show how motion, distance, and timing shape our universe perfectly. Every eclipse reflects a rare alignment of three celestial bodies exactly. Earth, Moon, and Sun dance together in a predictable gravitational rhythm. Yet that rhythm creates moments that feel completely unpredictable to humans. This contrast is what makes eclipses so deeply fascinating and unforgettable. We now understand they are rare from a human perspective only. In cosmic terms, they are natural outcomes of orbital mechanics constantly. Still, witnessing one remains a once-in-a-lifetime experience often. Many people remember their first eclipse more vividly than other events. That memory is shaped by emotion, silence, and sudden darkness together. It feels like time itself slows down during totality moments briefly. The world around you transforms into something almost otherworldly instantly. This transformation is what makes eclipses spiritually meaningful for many observers. Scientists, however, see eclipses as windows into solar mysteries and physics. They use these rare moments to study the sun's hidden corona. That glowing outer atmosphere reveals secrets about solar energy and behavior. These discoveries help us understand space weather affecting Earth systems daily. So eclipses are both beautiful and scientifically valuable at the same time. Few natural events combine wonder and research opportunity so perfectly together. Looking deeper, eclipses also remind us about cosmic scale of existence. Earth is just a small point in a vast moving universe. Yet from that small point, we can witness incredible celestial alignment. That realization often leaves people feeling humbled and inspired simultaneously. It changes how we see our place in the universe forever. Another important truth is that eclipses will not remain permanent forever. The Moon is slowly drifting away from Earth every single year. This gradual change will eventually alter eclipse visibility in future. That means today's eclipses belong to a unique cosmic era. We are lucky to live in a time of perfect alignment. Future generations may not experience total eclipses the same way. This adds urgency and value to every eclipse we witness today. Each event becomes a rare moment in Earth's long timeline history. People often gather together during eclipses, sharing collective wonder and silence. That shared experience connects strangers through a universal natural event. It is one of the few phenomena uniting people across cultures globally. Science explains eclipses completely, yet wonder still remains untouched and alive. That balance between knowledge and awe defines human curiosity perfectly always. We understand the mechanics, but still feel amazed every single time. This is what makes science not just informative, but deeply emotional. Solar eclipses teach us that understanding does not reduce beauty at all. Instead, knowledge makes the experience even more meaningful and powerful always. As we conclude, remember how rare your perspective in the universe is. You exist in a time where eclipses can be predicted accurately, yet still experienced with awe and emotional depth unchanged by science. That combination is what makes modern eclipse viewing so special today. Every eclipse you witness becomes part of your personal life story. It is a reminder that the universe is constantly moving and aligning. Nothing in space is truly random, but beautifully structured and timed. Even darkness during an eclipse is part of a larger cosmic design. That design continues long after the sun returns to full brightness. And life continues, but with a deeper appreciation of sky above. So the next eclipse you see, watch it with full awareness. Notice not only what disappears, but what the moment reveals inside. Because eclipses are not just about the sun being hidden briefly. They are about understanding how perfectly our universe actually operates always. And that understanding is the real wonder behind every eclipse event. The sky teaches us patience, precision, and perspective through its cycles. Every eclipse is a reminder that change is constant in universe. Yet some patterns remain beautifully consistent across time and space always. That balance is what makes our cosmos both stable and dynamic. And now, our journey through solar eclipses comes to a close, but the curiosity they inspire will continue far beyond this moment.